Welcome to the deep dive. We're here to cut through the noise and get you properly informed on the topics really shaping our world. And today, wow, we are plunging into something that's moving incredibly fast. It's way beyond those simple chatbots we first saw. We're talking about systems capable of genuinely complex thinking. The topic is AI reasoning in large language models, LLMs. It's a huge shift. And what's really striking is how much potential, especially for businesses, is still, well, basically untapped. We've waded through a ton of expert research, white papers, articles on this, our mission today, to pull out the absolute key insights for you. Think of it as your shortcut to getting up to speed on this genuinely transformative tech. We're going to unpack what AI reasoning really means and, maybe just as critical, what it doesn't mean. We'll explore why this isn't just, another buzzword, but potentially a multi-trillion-dollar opportunity for companies, how it's already being used in some pretty surprising ways, and of course, the big challenges that need figuring out before it goes truly mainstream. So yeah, get ready for a proper deep dive. We're going way beyond the headlines here with real examples and hopefully a clearer strategic picture for you. Okay, let's dig in then. When we say AI reasoning and LLMs, what are we actually talking about? It's got to be more than just spotting patterns, right?
It absolutely is. We're talking about the model's ability to go beyond that rote pattern matching and actually perform logical multi-step analysis or problem solving.
Okay, so like how a person might tackle a tricky puzzle.
Exactly. The LLM can break down a complex question into logical steps, understand the nuances in the language, pull together information from different places, and then, reach a conclusion. It's about getting the model to actually show its work, essentially.
Show its work. I like that. That makes it clear.
And the real breakthrough has been how this capability emerged. For ages, models just gave answers. But then came something called chain of thought prompting, or CUT-T.
CUT-T.
Yeah. And this basically guides the model explicitly to spell out those intermediate reasoning steps. And doing that dramatically improves accuracy for problems that need multiple steps. Things like arithmetic, sure, but also common sense reasoning tasks.
So it's like you're coaching them to outline their thinking process step by step. That makes a lot of sense.
Precisely. And it hasn't stopped there. It's gotten way more sophisticated. We now have these advanced frameworks like Atom of Thought's AOT and Trio Thought 2T.
AOT and TOT.
Right. These break reasoning down into smaller parallel units or explore multiple possible reasoning paths at the same time. The goal is to catch errors earlier, make it more robust. And then there's another one called REACT. That stands for Reason plus Act.
Reason and act. Okay.
Yeah, this is really cool. It integrates the reasoning part with using external tools. So the model can decide, okay, I need more info, and then query a database or call an API as part of solving the problem. They're not just thinking internally, they're doing things based on that thought process.
Wow. Okay, that integration with external tools feels like a massive leap forward. But it's still important to be clear, right? This reasoning we're seeing, it's often described as an emergent property.
That's the key technical point, yes. Comes out of their basic architecture, the transformer architecture, which is fundamentally designed to predict the next most likely word or token in a sequence. As these models get bigger and trained on more data, they get incredibly good at spotting really complex statistical patterns in language and logic. And this creates this powerful illusion and really looks like a thinking machine.
Which leads us straight into this really fascinating and honestly pretty central debate happening right now. Are LLMs truly reasoning like humans do? Or is it just an incredibly sophisticated, almost spooky level of pattern matching?
Yeah, that's the billion-dollar question, isn't it?
Yeah.
And the current scientific consensus, well, it seems to lean heavily towards the latter, towards pattern matching.
Really? Still?
For now, yes. The view is that LLMs don't think in the human sense of having beliefs, desires, or genuine understanding. They replicate the logical steps and structures they've learned from all the text data they ingested, but without possessing a true abstract grasp of why those steps work.
So, mimicking the form of reason without the substance, maybe. What are some of the key limitations then? The things that really highlight this difference? Because knowing that is vital if you want to use them effectively, especially in business.
Okay, well, one big one is how sensitive they are to irrelevant information. Stuff a human would just ignore.
How so?
Like, if you give it a math problem but add a completely unrelated sentence about the color of the sky, sometimes the LLM gets thrown off. A human just filters that out instantly. The LLM might try to incorporate it somehow, leading to errors. But maybe the most significant weakness, the one researchers point to again and again, is the lack of causal understanding.
Causal understanding, meaning cause and effect.
Exactly. LLMs are brilliant at spotting correlations, seeing that A and B often appear together in the data. but they lack a real-world model to understand if A causes B, or if B causes A, or maybe if some hidden factor C is causing both. In fact, studies show that on formal causal inference tasks designed specifically to test understanding of cause and effect, they often perform at levels barely better than random guessing.
Wow, that's quite a gap compared to human thinking, where causality is so fundamental to how we understand everything.
It's a huge gap. And tied into that are limitations in common sense and context. Even after processing literally trillions of words, LLMs can lack what we'd call basic common sense or a deep understanding of how the physical or social world actually works. This can lead to what researchers call brittle performance. They might seem brilliant one moment, then fail spectacularly or give nonsensical answers in slightly new situations they haven't seen patterns for before. And maybe most critically for complex tasks, these reasoning models can hit a wall. They face what's described as complete accuracy collapse when problems get beyond a certain level of complexity. They also consistently fail to actually use explicit algorithms or rules, even if you give them the rules and the solution steps. They prefer to mimic patterns rather than apply abstract principles.
Okay, so summing that up, incredibly powerful tools, amazing mimics of logic, but definitely not human brains in a box. It's more like they're geniuses at following recipes they've seen, but they can't invent a new dish based on fundamental cooking principles.
That's a pretty good analogy, yeah. Understanding these differences, where they shine and where they stumble, is absolutely crucial for deploying them effectively in an enterprise setting. You need to leverage their strengths while having guardrails for their weaknesses.
Right. So, keeping those limitations firmly in mind, why is AI reasoning suddenly such a hot topic, such an imperative now for businesses? Because current AI, the chatbots for customer support, the simple automation, they're useful, sure, but they often feel like they're just scratching the surface.
You've hit the nail on the head. Those initial applications delivered productivity gains, definitely. But they don't really tap into the deeper potential of AI for complex analysis, insight generation, and more autonomous decision-making. The real game-changing ROI, according to many experts and reports, is going to come from using LLMs as reasoning engines layered on top of a company's own data.
Reasoning engines on enterprise data.
Yeah.
Okay.
And the numbers being thrown around are staggering. Some estimates put the potential productivity boost at something like $4.4 trillion globally.
$4.4 trillion. That's enormous.
It's huge. But here's the kicker. There's a massive adoption gap right now. Despite these models getting incredibly capable, look at OpenAI's specialized O1 model hitting nearly 97% accuracy on advanced math problems, which shows a potential for high reliability.
97% on advanced math.
Yeah, near human expert levels. But despite that capability, one study found only about 23% of enterprises have actually managed to deploy these advanced reasoning models into production successfully. So massive potential, but still largely untapped in practice.
Okay, that gap is really interesting. Huge potential, low adoption so far. So where are we starting to see this potential being realized? What are some of those high-impact areas where AI reasoning is really set to shake things up for businesses?
Well, let's break it down into maybe 3 key zones where we're seeing major movement. First up is enterprise data analysis.
Okay, analyzing company data.
Exactly. But think beyond basic dashboards. LLMs are acting as powerful, unstructured data wranglers. They can read and understand complex information in natural language, emails, reports, transcripts, whatever, and draw logical connections across different data sets. Imagine being able to ask your system a high-level question like, what were the main factors driving the dip in Q3 profit? Or pinpoint any anomalies in our supply chain logs from last month, and getting a synthesized answer, not just a list of documents.
That's moving way beyond keyword search. That's getting actual answers from tangled messes of text and data.
Precisely. And it goes further. They can automate hypothesis generation. By spotting subtle patterns across vast amounts of data, they can suggest novel, plausible ideas for humans to investigate. We've seen some stunning examples, like GPT-4 suggesting new combinations of drugs for breast cancer that actually worked when tested experimentally, or finding subtle calculation errors buried deep in scientific papers.
Generating testable hypotheses, that's a capability normally requiring deep human expertise.
Right. And while we said they struggle with true causal inference on their own, they can be incredibly powerful co-pilots for human data scientists. They can help identify potential causal links in the data or run what-if scenarios, counterfactual reasoning much faster than a human could alone. We're also seeing them used to build intelligent knowledge graphs automatically. They can read across all sorts of data silos, emails, documents, databases, and figure out the relationships between entities, creating a unified view of company knowledge.
Like connecting the dots automatically across the whole organization.
Exactly. A prime example is Morgan Stanley. They built a custom GPT assistant trained on, I think, 100,000 of their own internal research reports. It allows their analysts to ask incredibly complex, context-rich questions and get synthesized answers grounded in that vast internal knowledge base. And the productivity numbers back this up. Bloomberg GPT is reportedly saving analysts over 10 hours a week. Cox Automotive cut the time needed to get insights from millions of documents by 88%. The gains are real and measurable.
Okay, enterprise data analysis is clearly huge. It's amazing how fast that's moving. What's the second big area?
Second area, context-aware recommendations. This is a really profound shift. We're moving beyond just matching keywords or past behavior.
Like people who bought this also bought.
Yeah, beyond that simple stuff. To systems that perform deep inference about the user's underlying intent and current context, even if their query is vague. Think about a bank's virtual assistant. Instead of just pulling up account balances, it might infer from recent activity, life events mentioned in secure messages, and current market conditions that you might be interested in, say, the specific type of mortgage or investment product, and then proactively recommend it with a clear explanation.
So it's understanding the why behind the user's interaction, not just the what.
Exactly. And the tech enabling this is pretty sophisticated. There are systems using what are called LLM reasoning graphs, LLMRGs.
Oh, LMRGs. Okay.
These create these dynamic, personalized maps, essentially showing the logical steps and inferences the AI took to arrive at a recommendation. It provides what they call chained graph reasoning, a transparent step-by-step explanation.
So you can actually see why it recommended something, not just a black box spitting out suggestions. That must build a lot more trust.
Huge difference. And the data shows it works. Studies have found that giving these contextualized explanations significantly boosts users' intention to actually act on the recommendation. Companies like Zalando reported, I think, 15% higher engagement and a 2.2% lift in revenue. Another company, Faber Labs, saw a 200% improvement in conversion rates with their system, Gora, that uses this kind of explainable reasoning. Transparency pays off.
Incredible. 200% improvement. Okay, so data analysis recommendations. What's the third key area?
Third big one is process optimization. This uses LLMs to continuously analyze how work gets done.
How so? Like watching workflows?
Kind of. They can analyze process data, think emails, chat logs between teams, project management updates, system logs to spot hidden inefficiencies or bottlenecks that humans might miss. Then they can propose improvements. For example, it might identify subtle communication patterns that consistently correlate with project delays, or it could enable more sophisticated AI-powered predictive maintenance by understanding technician reports in natural language. Yeah. And this leads directly to something called agentic process automation.
Agentic? Like AI agents. That sounds like a step beyond just analysis.
It really is. An LLM agent is basically an autonomous system. It uses an LLM as its core brain to understand a goal, reason through the problem, create a multi-step plan, and then crucially execute that plan by interacting with other software, tools, and APIs.
Okay, that sounds like a paradigm shift.
It absolutely is.
Yeah.
We're moving beyond traditional robotic process automation, RPA, which is mostly about automating repetitive, rule-based tasks. RPA bots are brittle. They break if the process changes slightly. LLM agents, though, can handle the ambiguity and variability found in real-world business processes. They can automate tasks that require judgment, interpretation, and planning the cognitive last mile that RPA couldn't touch.
What kind of tests are we talking about?
Things like complex insurance claims processing, monitoring drug safety reports for subtle signals, sophisticated contract review and analysis. Salesforce, for instance, reportedly cut I think it was $5 million from their outside legal counsel spending by using AI for contract review. Microsoft is building these capabilities into Copilot now with agents called researcher and analyst that can apparently help outline entire business strategies. And NVIDIA is using multi-agent systems collaborating AIs to manage complex supply chain logistics.
Wow, okay, those examples really bring it home. Data analysis, smart recommendations, and now these autonomous agents optimizing processes. The potential is clearly enormous, but getting there isn't magic. There must be hurdles. So let's talk practicalities. What are the tools making this happen? How are companies actually dealing with the challenges we talked about earlier? And, where is this all heading?
Right, the how. Okay, tool-wise, on one hand, you have the big proprietary advanced LLMs. Think OpenAI's GPT-4 family, including those specialized o1 and o3 reasoning models we mentioned, the ones hitting near 97% accuracy on tough math exams, showing they're ready for complex analytical work. Anthropic's Claude models are also major players here. Then you have the enterprise AI platforms from the tech giants. Microsoft Azure integrating OpenAI, IBM with Watson's, Google Cloud with Duet AI and PaLM 2 models. Microsoft 365 Copilot is a prime example, embedding those researcher and analyst reasoning agents directly into workplace tools.
So the big players are definitely leaning in.
Heavily. Yeah. But what's incredibly exciting and potentially disruptive is the rise of open-source reasoning models.
Open source. How do they compare?
Models like DeepSeek R1 are showing that really advanced reasoning capabilities can be achieved with open models, and the cost difference is dramatic. We're talking maybe 0.96 per million tokens for something like DeepSeek R1 versus $15, $30, even $60 per million tokens for some of the top proprietary ones.
Wow, that's orders of magnitude cheaper.
It's a game changer. It means enterprises can potentially achieve similar results, but at a fraction of the cost. And crucially, they can run these models on their own infrastructure on-premise or in a private cloud. That gives them way more control over their data, security, and customization. It really democratizes access to this powerful tech.
Okay, so the tools are evolving fast, both proprietary and open source. But what about those challenges we discussed earlier? The hallucinations, the lack of true understanding. How are companies actually mitigating those risks in production?
Yeah, the challenges are very real. For accuracy and hallucinations, remember, error rates in production can still be significant, maybe 15 to 38%, even for logically structured outputs. The number one technique right now is retrieval augmented generation, or RA.
RA, we hear that acronym a lot.
You do, because it's currently the most effective fix. RAG basically connects the LLM to a company's own trusted internal knowledge-based documents, databases, etc. Before generating an answer, the system retrieves relevant factual information from that trusted source and uses it to augment the prompt given to the LLM. This grounds the response in verified facts, dramatically reducing hallucinations and improving accuracy.
Got it. So you're forcing it to check its facts against your own trusted data before it speaks.
Essentially, yes. Then there's data privacy and security. Big concern, especially with cloud models. Risks of sensitive data leaking, or attackers using prompt injection to manipulate the AI. Mitigation here involves careful deployment choices, like using those open-source models on-premise or using private cloud instances. Plus, rigorous data anonymization techniques and strong AI governance frameworks are essential.
Makes sense. What about plugging these things into existing company systems? That sounds complicated.
It is. Integration with enterprise systems is often a major hurdle, connecting LLMs to legacy databases, various APIs, diverse data formats. It requires significant technical effort and what experts call clever orchestration. It's definitely not plug and play yet.
Okay. And the black box problem, not knowing why the AI decided something.
Yeah, explainability and trust, that's a huge barrier, especially in regulated industries like finance or healthcare. You can't just say, the AI said so.
Yeah.
The mitigation strategies here involve using those techniques we talked about, like chain of thought prompting or LLM reasoning graphs that force the model to expose its reasoning steps. Also, using other AI models, sometimes called LLM as judge systems, to continuously monitor, evaluate, and audit the outputs of the primary reasoning models for quality and safety.
Using AI to check AI.
It's becoming a key part of the solution stack. Then there's computational cost and latency. Running these huge reasoning models is expensive and can be slow. So companies are using optimized hardware, like GPUs and TPUs, techniques like model quantization, shrinking the model size, smart caching strategies, and often using a mix of models, maybe a smaller, faster model for simple queries and escalating to a larger reasoning model only when needed.
A multi-model approach.
Exactly. And finally, don't underestimate the workforce and cultural adoption challenge. You could have resistance from employees, or conversely, people over-relying on the AI without critical oversight. Mitigation here is all about comprehensive training, fostering a culture of collaboration between humans and AI, and very clearly defining the roles and responsibilities, the division of labor for different tasks.
That's a really practical overview of the hurdles and how companies are tackling them. So looking further out, what's the trajectory? Where does AI reasoning go next?
Well, we're likely to see several key developments. First, expect a boom in more specialized reasoning agents. Think AI agents purpose-built for specific roles like a financial analyst agent, a supply chain planner agent, a legal research agent. And these specialized agents might start collaborating in complex multi-agent systems to tackle really big problems.
So not just one giant AI, but teams of specialized AIs.
That seems to be the direction. Second, we're seeing the emergence of a whole new category, large reasoning models, LRMs. These aren't just general-purpose LLMs that happen to reason. They are models like OpenAI's O-Series or DeepSeek's R1 that are explicitly architected and trained for complex, multi-step logical reasoning tasks. They're achieving near-human expert levels on specific reasoning benchmarks. This signals a shift away from the idea of one model to rule them all, towards a more nuanced, multi-model, platform-based strategy where you pick the right model or agent for the specific job.
Interesting. Specialist models winning out.
For specific high-value tasks, potentially yes. Third, the future probably involves hybrid neurosymbolic systems. This means combining the strengths of LLMs, their ability to understand language and find patterns in massive data, with the strengths of traditional symbolic AI, which is much better at formal logic, rules, and causal reasoning. This could look like LLMs generating code that then runs in a deterministic symbolic system, or LLMs interacting with formal causal models to perform more reliable what-if analysis, getting the best of both worlds.
Okay, combining the new and the old AI approaches.
Exactly. Fourth, expect continuous learning and adaptation. Future systems won't just be trained once. They'll learn continuously from new data, user feedback, and interactions, becoming sort of ever-improving virtual employees. Fifth, democratization will accelerate. As open-source reasoning models get even better and the specialized hardware potentially becomes more accessible, powerful reasoning AI won't be limited to just the tech giants or huge corporations. Smaller enterprises will get access, likely spurring a wave of innovation, maybe through app marketplaces offering pre-built reasoning agents for specific tasks.
Leveling the playing field somewhat.
Potentially. And finally, this could lead to the rise of truly AI-native companies. Businesses designed from the ground up to leverage AI reasoning agents extensively in their core operations. These companies might operate with radically different structures and cost bases, potentially disrupting incumbents who are slower to adapt.
Okay, that paints a really dynamic picture of the future, so let's bring it all together for the listener. What does this all mean for you? If you're a leader in a business or just trying to understand this space, what are the key takeaways? What strategic steps should you be considering right now?
All right, let's try to boil it down to some concrete recommendations. First, and maybe most importantly, reframe AI as a core process, not just a tool. Don't just think about chatbots or standalone assistants. Think about how you can embed AI reasoning directly into your core business workflows for genuine cognitive automation.
So integrate it deeply, don't just bolt it on.
Exactly. Second, build a multi-model platform-based strategy. Avoid getting locked into a single vendor or a single type of model. Plan to use a mix proprietary open-source generalist LLMs, specialist LRMs, selecting the best tool for each specific task. Flexibility will be key.
Makes sense. Don't put all your eggs in one AI basket.
Precisely. Third, invest heavily in reasoning-aware talent and culture. This isn't just about hiring data scientists. It's about cultivating AI literacy across the board, fostering real collaboration between your AI experts, your domain experts who know the business, and your operations teams. There's a widely cited 46% skills gap in AI reported by enterprises. Addressing that is critical.
People and process are just as important as the tech.
Absolutely crucial. Fourth, prioritize building robust governance and evaluation infrastructure. This stuff is powerful, so you need strong AI governance policies, security protocols, and ways to measure if it's actually working well and safely. This means developing custom process-specific evaluation methods, maybe using those LLM as judge systems we mentioned for ongoing scalable quality monitoring. You can't just rely on generic benchmarks. And fifth, perhaps the most practical advice. Start with high-value, bounded use cases. Don't try to boil the ocean. Identify specific areas where AI reasoning can offer clear, measurable advantages, maybe automating a particularly complex internal analysis, enhancing knowledge discovery for your teams, or creating a next-gen customer support experience. Run pilot projects, demonstrate the value, learn, and then scale.
Start focused, prove the value, then expand. Good advice. It feels like the overarching message here, tying back to that untapped potential, is really about partnership.
That's exactly it. The ultimate vision isn't about AI replacing humans wholesale. It's about creating a powerful symbiotic partnership between the intuition, creativity, ethical judgment, and real-world understanding of human experts, and the incredible ability of reasoning AI to process vast information, see complex patterns, maintain consistency, and execute tasks tirelessly.
creating a kind of human AI super intelligence.
That's the
Yeah.
aspirational goal,
Yeah.
yes. Something that elevates our collective ability to innovate, to strategize, and to solve the really hard problems we face.
And that wraps up our deep dive today on AI reasoning in large language models. We've journeyed through what it is, its current limits, the huge opportunity that $4.4 trillion number sticks with you, and some concrete steps for harnessing it.
Yeah, and I think the key takeaway, if there's one thing to hold on to, is that shift in perspective. We're moving beyond AI as just a tool for efficiency, towards AI as a collaborative partner in thinking, combining human strengths, creativity, ethics, context with AI strength scale, atom recognition, logical consistency. That's where the real magic, the real value is going to be unlocked.
So maybe the final thought for you, our listener. Given how fast this reasoning AI is evolving, how might you proactively start thinking about creating that symbiotic partnership in your own work or within your organization? How can you move beyond seeing AI as just a smarter tool and start exploring it as a potential collaborator to genuinely enhance how you solve problems? Something to mull over.